Hello everyone and welcome. Today's video is where we finally begin to do useful things with our programs. So far we learned about data types, how to collect and output data and others, but it's pretty much useless if you don't do useful operations with it. And the most basic form of doing something useful is called conditional processing, which basically means doing or not doing something when a certain condition is met. Today we will also create our first working and complete program. True, very basic, but a complete functional program nonetheless, so that's already exciting. There are multiple forms of conditional processing: if else, if else if else, and the switch instruction. Let's start with the first one. It's very simple. If some condition is true, execute some codes. So you would have something like this. So I declared an int with a value of 32. Then I used an if condition to check if the value is greater than 19. And the way I did that was to put the condition to be checked between parentheses. And this condition must always produce a Boolean result. So age, 32, is greater than 19, yes or no, true or false. It can't be both or none or in between. Then I used a block of code starting at this opening curly bracket until this closing curly bracket, and whatever codes I put between these are the codes to be executed when this condition is true. So if I run it, you can see that indeed the program printed the age is greater than 19, whatever I put in this block of code, because indeed age is greater than 19 and this condition is true. However, if the value was smaller, for instance 18, which is not greater than 19, then the program would not execute this block of code. It would jump at the first instruction that follows after the if. So in our case, ended. Of course, if we can check if a condition is equal to true, we can also check if it's false. So we could have this, which reads precisely as it is. If age is greater than 58 is false, or in other words, if age is not greater than 58. In this case, I could have used the difference operator. Or obviously we can just check if age is less than 58. In fact, you should know that the implicit value to compare against is true. So actually I don't have to write is equal true. That's what it will check by default. So of course the inverse of this would be to check if age is greater than 58 without equals true. That's usually a sign of beginner's code to see conditions explicitly evaluated against Boolean values. So teach yourself to implicit check against truthness. But what if we already have a Boolean variable? What if we had something like this? This is one of the reasons why your Boolean variable should be named with something that signifies true or false, like can, is, are, should, was, etc. Because it reads like plain English, if today is Monday, and so on. On the other hand, if you wanted to compare if today is not Monday, how would that look like? Because I just said comparing with equals false is usually a sign of beginner's code. And in the case of the int, we could use the inverse operator of less than instead of greater than. But what is the inverse of nothing? Because here we don't have an operator. We just have a Boolean variable implicitly checked against true. So here we could use the not operator to negate or inverse the value of the Boolean variable. Something like this. And now it reads like if not today is Monday, or in other words, if today is not Monday. Anyway, what if you wanted to execute one set of instructions when a condition is true and another set when the condition is false? True, you could have two separate if statements, one after the other, but there's a more elegant way with the second form of conditional processing, the if-else. So, when our string is not equal to Monday, output some value, and when it is, output something else. But the else portion of this code would be executed for any other value other than the if portion of the code. What if you wanted to display multiple values for multiple conditions? And finally, there is also the version of if, else, when we have multiple cases and a fallback value when none previously matched, something like this. And in this case, the string would be compared against the value Monday, and if it's true, it executes this block. If it's not, it's compared against Tuesday, and so on and so forth, until the last block, if none previously matched, it will be executed, the else. You should also note that it is not mandatory to write the curly brackets of a block of code if there is a single instruction that follows after the condition like this. But you as a beginner should not use this, because again, only the first instruction after the condition is part of that condition. So you might write something like this, thinking that both instructions would be executed as part of the else branch, but that would not be the case. In fact, even Visual Studio shows to you that the second write line is written from the beginning of the line and not indented, to signal to you that it is not part of the else. And it gets even more complicated with nested conditional statements, because yes, you can have if statements inside other if statements like this. So first of all, we check if the hour is less than 7, meaning if you are still at night. On the else branch, we have another conditional where we check if we are in the first half an hour where we need to wake up, or in the second one where we need to go to work. But now imagine, what if I didn't put curly brackets for the blocks that follow after the conditions? Would this if actually become an else if from the previous condition or not? So you as a beginner always stick with blocks, even if there is a single instruction that follows. The last conditional processing that I'll discuss is the switch instruction. It does the same thing as an if, else, but it has a syntax difference. Its format is this. So we put the value to be checked between parentheses, just like we did for the if. Then we have multiple cases, just like we had the if, else, if previously. Finally, we have a default, which is the catch-all for the else that we had before. The only thing that is different is the break keyword, which actually separates each case. If we didn't put it, the execution would flow through multiple cases, so we could have this. And because we don't specify a break after each case, multiple values will be matched when we switch the number. So if the value of the number is 1, 3, or 5, the execution would fall through all the cases until it finds the first break and would execute the instructions before it. Similarly, for 2, 4, 6, if the value matches any of these cases, it will execute this instruction. And it is mandatory to have at least one break, and it is usually put after the default, after the else, so to say. In the version using if and else, we could theoretically write a separate else if case for each of the values 1, 3, 5 and duplicate the functionality in them, but as we'll soon learn, duplicating functionality is a big no-no in programming. So instead, we could have a single check and use logical operators to group multiple Boolean checks into a single Boolean result like this. So in plain English, if number is equal to 1 or number is equal to 3 or number is equal to 5, execute this block and so on and so forth. At the end of this lesson, there is one more topic to discuss, which is switch expressions, which are also kind of a switch, but has a different functionality that is based on stuff that we haven't learned yet. So we'll address it when we'll get there. Finally, a piece of advice. Try to always compare against truthness, not falseness, and try not to use double conditionals like naming your variable is not Monday and then checking if not is not Monday, because that makes it harder to reason about. That's it, folks. As a homework, try to write a program that asks some value from the user using console readline, like we learned in the lesson input and output. And with that value, based on some conditions, output various texts. Like for instance, asking the user their zodiac sign and making some predictions based on the value they entered. Let me know how that went in the comments, if and where you got stuck and so on. If you enjoyed this video and you learned something from it, compliment me by liking it and perhaps subscribing to the channel. And until next time, thanks for watching and I'll see you in the next tech frame.